Rakhasiya, and today I will be explaining about cryptographic project which is on steganography. These are our these are our group members which have worked together to make this project possible. So now let me start with what is steganography. So basically steganography is method to hide a secret message or data into another media file. There are many types of steganography. Some of them are image steganography, video steganography, and audio steganography. Our project mainly focuses on image steganography. So basically image steganography is hiding text message into image such that the image steganography in which we have inserted the secret message cannot be differentiated with the original image. There are several methods to do image steganography. We will be using least significant bit technique. So now let us understand how least significant bit work. Image is made up of pixel and the each pixel can be represented in RGB form. You can see here. In each pixel, we are changing only the last 2 bits of each pixel's RGB value. In this example, we have taken a pixel. So in left side image, it is the original pixel, and on the right side, is inserted in the pixel with the help of LSB algorithm. So we can conclude that it cannot be detected with a human eye. So now I will explain LSB algorithm in detail. LSB algorithm is divided into two parts: image encoding and image decoding. Encoding part. We will take an image and our secret message. Now we will convert both into a binary format. Message will be only inserted if its length constraint is satisfied. We will flip the least significant bit of each pixel value with our message bit. And in decoding part, we will insert the image encoded message. We will iterate to each pixel and store the last 2 bits in group of 8 and message will be formed. So here are the some uses of algorithm. So this algorithm can be used in military purposes, invisible watermarking, and now my friend Kevin will demonstrate about the code. Thank you.
Thank you, Deep. So now I am going to demonstrate our project. So as you can see, we created two files. One is for encoding and one is for decoding. So in encoding, basically user give input of secret message and image, and we create a encoded image. And in decoding, we give input as a encoded image, and we retrieve the secret message. So now I'm going to explain both of these files one by one, and user can use any of this file as per their requirement. So first, let me explain this code. Here in encoder.py, we first ask user for image as an input, in which image they want to store their message. Then we ask user the message, which message they want to hide, and then we call this encoder function, and we pass these two parameter, file name and message, right? So in this encoder function, basically first we convert our image into RGB format, and then we convert our binary message into our message into binary message, sorry. So then what we do, we check the constraint. Like if our message is too long for the image, we stop the process and we show this message to user that message is too long to encode in the image. So in this case, user need to use a larger file than the current file, so it can store its secret message. And if our message pass this constraint, we add delimiter to our message. Now why we add this delimiter? Because it shows our, when we decode our image, if there is a no delimiter pass, we can identify that in this image there is no secret message. And if we able to identify the delimiter, so we can guess that okay, there is a secret message, and that secret message we can return. Okay, and then what we do, we iterate every bit of our message, and we change our last significant bit of each pixel of image by that bit. Okay, and this for loop does the same thing, and here we after this we iterate our pixel by one index. Okay, and then finally store our encoded file name, finally store our encoded image as a new file name, which is current file name underscore output.png, so user can easily identify that. Okay, so let me run this code. So it first asks for file name. I can use any image here. I am going to use image one. Now it asks for a message, so I am saying hello Kevin. Okay, so as you can see, the new image file is generated, which is our encoded image, which is with name in image underscore one underscore output dot png. Okay, so now if I have a receiver and I need to retrieve a message from this image, how I can do? I simply pass this image path to this decoder function, and this decoder function give me the output. How it is work? So it asks for the file path, and then it calls this decoder function, and it does the same but in a reverse manner of encoder function. So it first convert the image into RGB format, and we declare a variable binary message in which we are going to store our message, right? And then we iterate from each pixel of our image, and increase it one by one, and we store least significant bit into this binary message, as you can see here. Now we also check for the delimiter, as I say that the delimiter we added in the message. So if we are able to identify, if we identify that there is a delimiter, we are sure that we need to break from this, so we can give the secret message to user. Okay, so now we convert our message to the string and return it to user. So if I run this, it asks me for the image path. So as you can see, like it shows us the secret message which we hide in this image, which is hello Kevin. And if we see this, both of this image, which is this and this, the one thing is very common, that both are the image look identical, but they are not. This image does not contain any message inside it, but this image contain a message which is hello Kevin inside it. But a normal human eye cannot detect that thing. That is the advantage of our LSB algorithm. Thank you.